February 22nd, 1943, near Sbeitla, Tunisia. A reconnaissance patrol from Schwere Panzer-Abteilung 501, Germany's elite heavy tank battalion, moved through the olive groves in the late afternoon light. These men had arrived in North Africa 3 months earlier as the second unit in the entire German army to receive the Tiger tank. They had spent December destroying British Shermans at Tebourba, January hunting American armor through the Atlas Mountains, and February proving that the 56-ton Tiger could shatter any Allied formation it encountered. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. But on this particular afternoon, the Spähtrupp wasn't hunting in a Tiger. They were examining something they had never seen intact before. An American M4A1 medium tank, serial number USA3067641, abandoned by its crew during the chaotic American withdrawal from Spähtla. The tank bore a name painted in white letters across its olive-drab hull: War Daddy 2. The reconnaissance troops circled the Sherman cautiously. Every tanker in North Africa knew the Americans had brought these new medium tanks to Tunisia, but capturing one operational and intact was different from destroying one at range. The patrol leader, an Obergefreiter who had personally witnessed Tigers knock out 20 Shermans during the Battle of Sidi Bouzid 8 days earlier, approached the vehicle with professional curiosity rather than fear. His men had been fighting American armor for barely 2 months. The Sherman represented an enemy they were still learning to understand. What happened next changed the trajectory of German tank evaluation for the remainder of the war. The Spähtrupp didn't destroy the Sherman. They didn't strip it for parts. They didn't even report it as another battlefield trophy. Instead, recognizing that this was the first American medium tank captured intact and operational by German forces, they made a decision that would send War Daddy 2 on a 4.5-day, 217-mile journey to the port of Sfax, then across the Mediterranean to Germany itself, and finally to the most important weapons testing facility in the Third Reich. The Sherman they captured that day wasn't exceptional by American standards. It was an early production M4A1, one of 134, built by Lima Locomotive Works in July of 1942. It had the distinctive cast hull that characterized the A1 variant, the early differential volute spring suspension, and the standard 75mm M3 gun in a short-gun mantlet. On the front hull, centered between the driver and assistant driver hatches, someone had carefully painted the unit insignia, a mailed fist clutching 3 lightning bolts, the symbol of Company G, 3rd Battalion, 1st Armored Regiment. For the American crew who had abandoned it during the disaster at Spähtla, War Daddy 2 was just another tank in a force that would eventually produce 49,000 Shermans. For the Germans who captured it, this 33-ton machine represented their first opportunity to comprehensively examine American tank design philosophy, industrial capability, and technological approach to armored warfare. They couldn't know that within 4 months, this single Sherman would be driven by Germany's Minister of Armaments and War Production, tested alongside the Panther and Tiger at a demonstration attended by the highest ranks of German industry and military leadership, and featured in propaganda comparing German and American tank capabilities. The journey began immediately. According to an article that appeared in the propaganda magazine Die Wehrmacht, personnel from the Spähtrupp manned the captured Sherman and drove it 350 kilometers across Tunisia to Sfax. The journey took 4.5 days. Think about that timeline. German tank crews, who had spent months watching Panthers and Tigers, break down every 400 to 500 miles, according to Albert Speer's own assessment, were now driving an enemy tank across North Africa for 4 consecutive days without mechanical failure. They weren't nursing it along supply roads with breakdown crews standing by. They were moving it as quickly as possible to the coast before Allied forces could regroup and counterattack. The Germans marked their prize carefully. On the hull side, they painted an inscription, Nicht ausschlachten, für Auquar, Prou, Erbutet durch Thai, Pays, Rukter. Translation: Don't cannibalize. For Army High Command Weapons Office, captured by 1st Panzer Regiment 5. This wasn't standard procedure for battlefield salvage. This was a directive that meant something far more significant than tactical reuse. This Sherman was being earmarked for the Heereswaffenamt, the Army Weapons Office, the organization responsible for evaluating, testing, and recommending weapons for the entire German military. At Sfax, War Daddy 2 was loaded onto a ship and transported across the Mediterranean to Germany. By the time it arrived, the Sherman had already travelled farther under German control than many German tanks managed during their entire operational lives. At the Kummersdorf Proving Grounds, 25 kilometres south of Berlin, the Sherman received its official German designation Versuchsfahrzeug, number 259, Test Vehicle 259. It was assigned the military license plate WH05894117. And then German engineers did something that reveals how seriously they took this evaluation. They annotated every surface of the tank, armour thickness in millimetres, angle of slope in degrees. Every plate, every surface, every protective element was measured, recorded, and marked directly on the vehicle itself. Photos from Kummersdorf show War Daddy 2 covered in white stenciled numbers and angles, a physical data sheet that German engineers could reference while conducting their tests. The cast hull showed its thickness at multiple points. The glacis plate revealed its 47-degree slope. The turret armour displayed its measurements for front, sides, and rear. This wasn't casual examination. This was systematic, comprehensive engineering analysis. But the Germans didn't just measure the Sherman. They had to understand it, and understanding required comparison. Kummersdorf maintained an extensive collection of captured Allied armour, Soviet T-34s and KV tanks sent back from the Eastern Front, British Matildas and Churchills recovered from North Africa and the Dieppe raid, American M3 Lee tanks captured earlier in Tunisia. War Daddy 2 joined this collection not as a curiosity, but as a specimen requiring urgent evaluation because by February of 1943, Germany faced a strategic problem that no amount of Tiger superiority could solve. The Americans were coming, not in hundreds, in thousands. Intelligence estimates suggested American industrial production exceeded German capacity by ratios that seemed impossible. Reports from Tunisia indicated that American units, despite their tactical inexperience demonstrated at Kasserine Pass, were learning rapidly. The M4 Sherman appeared to be mass-produced with a standardization and interchangeability that German manufacturers could barely comprehend. And perhaps most troubling, initial battlefield encounters suggested that while the Sherman couldn't match the Tiger in armour or firepower, it possessed characteristics that German tanks increasingly lacked: reliability, mechanical simplicity, and the ability to actually reach the battlefield without breaking down. At Kummersdorf, German engineers began their evaluation with the power plant. They started the engine. It ran. They drove the tank around the testing grounds. It drove. These observations might seem trivial, but for Germans struggling with the chronic, mechanical failures of the Panther and the fuel consumption nightmares of the Tiger, the Sherman's automotive reliability represented something approaching revelation. The tank used a Continental R975 radial engine, an adaptation of an aircraft engine that produced 425 horsepower. Not exceptional by German standards, the Panther's Maybach HL230 produced 700 horsepower, but the Continental started reliably, ran smoothly, and most importantly, it didn't require the constant mechanical attention that characterized German tank engines. The transmission fascinated the evaluation team. American tanks used a controlled differential system that allowed precise turns and smooth operation. German tanks, by contrast, used crash gearboxes that required skill and strength to operate effectively. New German tank crews often needed weeks to master gear changes. American crews could drive effectively after hours of training. The Sherman's transmission represented a deliberate trade-off, giving up some theoretical efficiency for practical operability. The suspension drew particular attention. The vertical volute spring system wasn't sophisticated. It wasn't elegant. It certainly wasn't the advanced torsion bar suspension that German engineers preferred, but it was simple, durable, and easily repairable in field conditions. Each bogie unit could be replaced without specialized tools. Springs could be changed without lifting the entire tank. For an army fighting across thousands of miles of territory with extended supply lines, the Sherman's maintainability offered advantages that elegant engineering couldn't match. But the evaluation that mattered most wouldn't happen at Kummersdorf. The comprehensive field test, the demonstration that would shape German understanding of American tank capabilities, was being planned for early June at another testing facility, the artillery range at Hillersleben. And this demonstration wouldn't be a private technical evaluation. This would be a Rüstungstagung, an armaments conference presided over by Reichsminister Albert Speer himself, attended by leaders from German industry, high-ranking Nazi officials, and senior military officers. War Daddy 2 would be the centerpiece of a propaganda campaign comparing German and Allied tank capabilities. The timing was deliberate. By June of 1943, Germany needed a narrative. The disaster at Stalingrad had ended 3 months earlier with the surrender of the Sixth Army. The Afrika Korps would surrender in Tunisia on May 12, less than 3 months after War Daddy 2 had been captured with 230,000 German and Italian troops going into Allied captivity. The Eastern Front was consuming German armour at unsustainable rates. The Western Allies were clearly preparing for an eventual invasion of Europe. German industry needed to accelerate production, while improve quality, but the Panther program was plagued with mechanical problems, and the Tiger was too expensive and complex for mass production. What Speer needed from the Hillersleben conference was clarity. Could German tank design maintain its qualitative superiority against American quantitative production? Were German engineering principles sound, or did they need fundamental revision? How should Germany's limited industrial capacity be allocated between competing tank programs? These questions required more than laboratory testing. They required demonstration, comparison, and political theatre. The program for June 6th and 7th included meetings and demonstrations of the latest German equipment alongside captured Allied vehicles. Unlike the regular weapons demonstrations that Hitler typically attended, this conference would proceed without the Führer's presence. Speer had learned from his experience at Kummersdorf West in March of 1939, when Hitler watched rocket tests and remained skeptical of their potential. This conference would focus on practical evaluation rather than political spectacle. Among the demonstrations planned, one exercise would prove particularly revealing: a hill-climbing test. German engineers had selected a slope at Hillersleben that would challenge any tank's power-to-weight ratio, traction, and transmission capability. Multiple vehicles would attempt the climb. Some would succeed, some would fail, and every success or failure would be witnessed by the men who controlled Germany's industrial capacity and military production priorities. War Daddy 2 was prepared for this test. German technicians had spent months examining every system, understanding every component, and documenting every characteristic. The propaganda magazine Die Wehrmacht had already begun framing the narrative. An article described the Sherman as one of the special accomplishments of the North American laboratories and quite a praiseworthy product of the North American steel industry. This wasn't the dismissive language typically used for enemy equipment. This was grudging respect, carefully calibrated to acknowledge American capability while maintaining German superiority. But respect in propaganda wasn't the same as understanding in practice. The German engineers who had driven War Daddy 2 from Tunisia to Sfax, who had tested it at Kummersdorf, who were now preparing it for demonstration at Hillersleben, had begun to recognize something that would have been heresy to admit publicly. The Americans had made fundamentally different choices about tank design, and some of those choices might be correct. June 6, 1943. Hillersleben Artillery Range, approximately 150 kilometers west of Berlin. The morning air carried the scent of diesel fuel and cordite as Germany's industrial and military leadership assembled for the armaments conference. Reichsminister Albert Speer arrived, accompanied by industrialists whose factories produced Germany's tanks, officials from the Nazi Party apparatus, and senior officers whose decisions would determine how Germany's dwindling resources would be allocated among competing weapons programs. The Hillesleben range had served as a proving ground since the 1930s, a vast expanse where artillery pieces could be fired at maximum range and armoured vehicles could be tested under realistic conditions. Today's demonstrations would include the latest German developments, the Panther tank that was supposed to counter the Soviet T-34, the Tiger that already dominated battlefields through sheer firepower and protection, and the experimental Ferdinand tank destroyer that mounted an 88mm gun in a heavily armoured casemate. But the demonstrations would also include captured enemy vehicles, because Speer understood something that many German officers refused to acknowledge. You couldn't defeat an enemy you didn't understand. War Daddy 2 sat among the vehicles prepared for demonstration, its American markings still visible beneath the German crosses painted on its hull. Next to it stood an M3 Lee tank numbered 147, also captured in Tunisia, its sponson-mounted 75mm gun representing the previous generation of American tank design, British Churchill tanks, Soviet T-34s, and various other captured Allied vehicles completed the collection. Each represented a different approach to armoured warfare, a different set of engineering compromises, a different national industrial philosophy. The centrepiece of the demonstrations would be the hill-climbing exercise. German engineers had selected a slope that would test each vehicle's power-to-weight ratio, transmission efficiency, and traction characteristics. This wasn't abstract laboratory testing. This was practical evaluation of the kind that determined whether a tank could maneuver effectively across the broken terrain of North Africa, the bocage of France, or the rolling steppes of Russia. In armoured warfare, mobility meant survival. A tank that couldn't climb a slope, couldn't take defensive positions, couldn't pursue retreating enemies, couldn't escape encirclement. The Ferdinand went first. At 65 tons, the massive tank destroyer represented the extreme end of German heavy armour philosophy. Maximum armour, maximum firepower, minimal mobility. Its Porsche-designed electric transmission, which used gasoline engines to generate electricity that powered electric motors connected to the drive sprockets, was theoretically sophisticated but practically problematic. The Ferdinand approached the slope with its engine roaring, began the climb, and quickly lost momentum. The tracks spun, grabbed, spun again. The massive vehicle stalled halfway up the incline. Speer watched, then walked away as the Ferdinand failed to make progress. The message was clear. Theoretical superiority meant nothing if the vehicle couldn't perform basic tactical maneuvers. The Panther was next. Germany's answer to the T-34. The Panther mounted a 75mm gun with excellent armour penetration, carried frontal armour that could defeat most Allied anti-tank weapons, and incorporated sloped armour principles learned from captured Soviet tanks. On paper, it was magnificent. In practice, as Speer already knew from reports from the Weapons Testing Office, the Panther suffered from chronic mechanical problems. Its Maybach HL230 engine was powerful but temperamental. Its final drive units failed regularly. Its transmission, while theoretically superior to the Shermans, required constant maintenance and frequently broke under combat stress. The Panther approached the same slope. It climbed further than the Ferdinand had managed, its tracks gripping the earth as the engine strained. But halfway up, something in the drivetrain failed. The Panther stopped, its engine still running but unable to transfer power to the tracks. Engineers rushed forward to examine the problem. The demonstration continued, but the Panther remained on the slope, a 45-ton monument to the gap between German engineering ambition and industrial reality. Then came War Daddy 2. A German driver climbed into the commander's hatch. The Americans placed their tank commanders in a proper cupola with good visibility. Another detail, German observers had noted, and started the Continental engine. It fired immediately, settling into a steady rumble. The driver engaged the transmission. The Sherman rolled forward smoothly, approached the slope, and began climbing. The 33-ton tank ascended steadily. No dramatic engine roar, no spinning tracks, no mechanical drama. The Sherman simply climbed the hill that had defeated both the Ferdinand and the Panther, reached the crest, and kept going. It didn't make the slope look easy. The strain on the engine was audible. The tracks threw dirt as they gripped, but it succeeded where German tanks had failed. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Speer and the assembled observers watched in silence. Some of the industrialists present controlled the factories that produced Panthers and Tigers. Some of the officers commanded the units that fought in those tanks. Every person witnessing the demonstration understood the implications. American tanks weren't superior to German tanks in armor or firepower. The Sherman's 75mm gun couldn't penetrate a Tiger's frontal armor at combat ranges. The Sherman's maximum armor thickness of 75mm couldn't stop an 88mm round from a Tiger or a Panther's 75mm high-velocity gun. But the Sherman worked. It started reliably. It drove predictably. It climbed hills that German tanks couldn't manage. And perhaps most importantly, America was building them by the thousands, while Germany struggled to produce hundreds of Panthers and Tigers. The demonstrations continued through both days of the conference. German engineers conducted comparison tests between the Sherman and the Panther, evaluating acceleration, turning radius, fuel consumption, and maintenance requirements. Every test reinforced the same uncomfortable conclusion. American tanks represented fundamentally different design priorities, and those priorities might be better suited to industrial-scale warfare than German engineering perfectionism. The Sherman's Continental radial engine produced less power than the Panther's Maybach, but it was adapted from a proven aircraft engine that had been in production for years. American factories could build them reliably and quickly. The Maybach was more powerful, but required precision manufacturing that took time and resources. The Sherman's controlled differential transmission was simpler than the Panther's regenerative steering system, but simplicity meant reliability and ease of repair. German transmissions offered theoretical advantages that disappeared when the transmission failed after 200 miles of operation. The Sherman's vertical volute spring suspension wasn't as sophisticated as the Panther's torsion bar system, but each bogie could be replaced in the field with basic tools. German torsion bar suspension required specialized equipment and substantial disassembly. The Sherman's standardized parts meant that components from one tank could be swapped to another with minimal modification. German tanks, even within the same model, often had variations that prevented easy parts interchange. But the most significant revelation wasn't mechanical, it was philosophical. The Germans had designed their tanks to win individual battles through superior performance. The Americans had designed their tanks to win the war through superior production. The Sherman wasn't trying to be the best tank on the battlefield. It was trying to be good enough, in sufficient numbers, with enough reliability, to overwhelm German forces through sheer presence. Albert Speer understood this distinction. In his autobiography, Inside the Third Reich, published decades after the war, he would recall reports from Italy about Sherman cross-country mobility. The Sherman climbs mountains our tank experts consider inaccessible to tanks. One great advantage is that the Sherman has a very powerful motor in proportion to its weight. Its cross-country mobility on level ground is, as the 26th Panzer Division reports, definitely superior to that of our tanks. This wasn't grudging admission after defeat. This was professional assessment during the war itself. Speer recognized that German tank development had pursued excellence at the expense of production efficiency. The Tiger was an extraordinary weapon. Its 88mm gun could destroy any Allied tank at ranges where return fire was impossible. Its armor could shrug off most Allied anti-tank weapons, and its psychological impact on Allied troops was substantial. But it cost more than 3 times as much to produce as a Panther, required 5 times the manufacturing hours of a Panzer IV, and consumed fuel at rates that Germany's dwindling petroleum reserves couldn't sustain. The Panther was supposed to solve this problem by combining T-34-style sloped armour with superior German engineering. But the development had been rushed. The design was overly complex, and the result was a tank that spent more time under repair than in combat. Early Panthers sent to the Battle of Kursk in July of 1943, 1 month after the Hillersleben Conference, suffered catastrophic failure rates. Transmissions seized, final drives broke, engines caught fire. Of the 243 Panthers that began the offensive, only 43 remained operational after 5 days. Meanwhile, American Sherman production continued to accelerate. 11. Different factories produced Shermans and their variants. The Lima Locomotive Works that built War Daddy II was just one of multiple producers that included Pressed Steel Car Company, Pacific Car and Foundry, Federal Machine and Welder, and the Fisher Body Division of General Motors. Each factory used standardized designs and interchangeable parts. Production methods incorporated assembly line techniques that Henry Ford had pioneered for automobiles, adapted to the complexity of armored vehicles. By the end of 1943, American factories would produce over 21,000 tanks. German production for the same period would total approximately 10,000 tanks of all types, including the smaller Panzer IVs and assault guns. And American production was accelerating while German production struggled against Allied bombing, resource shortages, and the dispersal of industry to protect against air raids. The Germans at Hillersleben who watched War Daddy II climb, that hill understood these statistics. They knew the Sherman represented more than just a tank. It represented an industrial system that Germany couldn't match. Every Sherman rolling off an American production line meant another tank that German forces would face in North Africa, in Italy, and eventually in France. Every hour spent repairing a Panther transmission was an hour that tank wasn't fighting. Every Tiger that broke down hundreds of miles from the nearest repair facility was a strategic liability, regardless of its tactical superiority. But understanding the problem and solving it were different challenges entirely. Germany's industrial system had evolved differently from America's mass production model. German manufacturing emphasized craft precision and quality control, producing smaller numbers of more sophisticated products. This approach worked for luxury automobiles and precision instruments. It was less effective for producing thousands of tanks, while simultaneously building aircraft, submarines, artillery, small arms, and all the other weapons required for total war on multiple fronts. Speer had been appointed Minister of Armaments and War Production in February of 1942, replacing Fritz Todt, who died in an aircraft accident. Speer brought organizational skills and political connections that enabled him to rationalize German production to some degree. He reduced model variations, standardized components where possible, and implemented efficiency measures that increased output. Under his management, German armaments production peaked in 1944 despite intensifying Allied bombing. But even Speer couldn't fundamentally transform the German industrial system to match American production methods. The infrastructure wasn't designed for it. The workforce wasn't trained for it. The supply chains couldn't support it. And the strategic situation in June of 1943 meant Germany was already fighting on multiple fronts with resources stretched beyond sustainability. The Hillersleben Conference concluded with presentations about future German tank development. The Tiger II was discussed, promising even heavier armour and more powerful armament. Various Panther improvements were proposed to address the mechanical problems. None of these solutions addressed the fundamental mismatch between German design philosophy and industrial reality. War Daddy II returned to Kummersdorf after the conference, where it remained as a test vehicle. German engineers continued examining it, conducting additional trials and documenting its characteristics. Some of the data gathered influenced later German tank development, particularly regarding the benefits of simpler, more reliable systems. But the fundamental lesson that numerical superiority based on reliable, mass-produced equipment could overcome tactical superiority of individual weapons was one that Germany couldn't act on, even if they fully accepted it. The propaganda campaign that accompanied the Hillesleben conference carefully framed the narrative. Die Wehrmacht magazine ran articles comparing German and American tanks, emphasizing the Shermans' praiseworthy engineering while highlighting German superiority in armor and firepower. The weekly newspaper Das Reich published similar assessments, describing the Sherman as an accomplishment of American industry, while reassuring readers that German tanks remained superior where it mattered. But propaganda couldn't change mathematics. By the time War Daddy II was tested at Hillesleben, the outcome of the tank war was already determined not by which nation built the best individual tank, but by which nation could field the most tanks where they were needed. The Tiger might destroy 5 Shermans before being knocked out, but if America could build 10 Shermans for every Tiger that Germany produced, the exchange ratio favored America. The crew of War Daddy II never knew what happened to their tank. Company G, 3rd Battalion, 1st Armoured Regiment, had abandoned it during the retreat from Sbeitla on February 22nd. They probably assumed it was destroyed or stripped for parts like dozens of other American tanks lost during the Kasserine Pass battles. They couldn't have known that their tank would be driven across Tunisia by German crews, shipped to Germany, tested at the Reiches Premier Weapons Facility, demonstrated to the Minister of Armaments, and featured in propaganda comparing American and German industrial capabilities. For the American tankers who fought in North Africa during those desperate early months of 1943, the Sherman was simply their vehicle, neither loved nor hated, just the tool they were given to do their job. They didn't consider its historical significance or its role in industrial warfare. They worried about more immediate concerns, whether it would start in the cold desert mornings, whether they could spot German tanks before being spotted, whether they could survive if an 88mm round penetrated the armor. But War Daddy II survived its capture to tell a different story. Not a story of tactical battles won or lost, but a story of strategic victory achieved through industrial capacity. The Sherman's legacy wasn't built on battlefield superiority. It was built on reliability, producibility, and presence. American factories built 49,000 of them. They fought in North Africa, Sicily, Italy, France, Belgium, the Netherlands, Germany, and the Pacific. They equipped British, Free French, Polish, South African, and Soviet forces through Lend-Lease. They remained in service with various militaries into the 1970s. The Germans who examined War Daddy II at Kummersdorf and Hillesleben understood what they were witnessing, even if they couldn't fully articulate it or act on it effectively. American tank design represented a different kind of superiority, not the superiority of the master craftsman producing an exquisite individual piece, but the superiority of the industrial system producing good enough products in overwhelming quantity. The Sherman might not win every individual tank duel, but Shermans as a collective force would win the war. Years after the war ended, veterans from both sides would share their perspectives on the tanks they fought in and against. German tankers generally praised the Tiger and even the temperamental Panther when it worked properly, while acknowledging their mechanical vulnerabilities. American tankers had mixed feelings about the Sherman, appreciating its reliability while wishing for better armor and a more powerful gun. But appreciation and preference didn't determine the war's outcome. Production and presence did. War Daddy II disappeared from historical records after the war. Kummersdorf was captured by Soviet forces in April of 1945. The testing facility contained numerous captured Allied vehicles, including several Shermans, at least one M, 3 Lee, various British tanks, and Soviet equipment. Most of these vehicles were either destroyed during the final battles or taken by Soviet forces as war trophies. The specific fate of serial number USA 3067641 remains unknown, but the tank's brief moment in German hands revealed a truth that transcended individual battlefield encounters. The Americans hadn't sent their best tank to fight the Germans. They had sent enough tanks. They hadn't designed a vehicle that could penetrate Tiger armor from the front. They had designed a vehicle that could be built in 11 factories simultaneously, that could be shipped across 2 oceans, that could be maintained by crews with limited training, and that could continue fighting as long as there were factories in Detroit and Pittsburgh and Lima producing replacements. The hill at Hillersleben that War Daddy 2 climbed in June of 1943 wasn't just a test of horsepower and traction. It was a demonstration of different philosophies colliding. German engineering pursuit of tactical perfection meeting American industrial commitment to strategic sufficiency. The Panther and Ferdinand failed that test not because German engineers were incompetent, but because they had been asked to solve the wrong problem. They had been asked to build the best possible tank when what Germany needed was enough adequate tanks. The Sherman succeeded at Hillersleben because it was designed to succeed at exactly that kind of task, not to be perfect, but to be present, functional, and numerous. Albert Speer and the German observers who watched that demonstration saw their strategic dilemma illustrated in mechanical terms. Superior individual weapons couldn't overcome superior industrial systems. Excellence in craft couldn't defeat excellence in production. This was the real lesson of War Daddy 2. Not that German tanks were inferior, they often weren't, at least not individually. Not that American tanks were superior, they frequently weren't, at least not in direct combat. But that in industrial warfare, the definition of superiority had changed. The best tank wasn't the one with the thickest armor or the most powerful gun. The best tank was the one that showed up to the battle, started when needed, and had another one behind it when it was destroyed. Germany learned this lesson at Hillersleben in June of 1943. But learning a lesson and being able to act on it were different capabilities. Germany's industrial system, resource constraints, and strategic situation meant that even perfect understanding couldn't change the outcome. The war would continue for another 2 years, and American Shermans would continue rolling off production lines, crossing oceans, and climbing hills that German tanks couldn't manage, not because American engineering was necessarily better, but because American industry was undeniably more powerful. War Daddy 2 disappeared into history, but the truth it revealed remained. In modern industrial warfare, showing up was more important than being perfect. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.